SQL Server database security. In this nugget, we're going to talk about securing the elements within a database itself. We'll start with the basics of database security, including users and roles. We'll look at some of the encryption options that can help protect the data in a database. And we'll look at SQL Server's policy-based management framework as a way of creating security policies. And we'll also look at SQL Server's audit plans. Let's start by looking at the basis of database security. We'll go into My Database, and in the security area, I've set up a user called Dave. Let's take a look at Dave. Now, Dave belongs to a database role, two of them actually, data reader and data writer. We'll talk about roles in just a second, but just like the instance or server roles are designed to provide certain pre-configured sets of permissions at the instance level, these database roles are designed to provide certain pre-configured permissions at the database level. Now, this particular user, Dave, exists inside the database. This is not an authentication mechanism, though. This is a way of mapping his login, Dave, to this database. If we go back to the overall server, to security and logins, we can see that there is a login called Dave. So when someone authenticates to the SQL Server instance using this login, and then they attempt to access this database, that login will be mapped to this user, and the login will pick up the database permissions defined here. So Dave is able to read and write data from the database. In addition to these database roles, I can also specify individual securables. If I search for objects of a specific type, you can see that I can specify permissions for the database as a whole, stored procedures, tables, views, pretty much every type of object that lives inside the database. In this case, I've selected a table named My Table, and I've told Dave that he is allowed to alter the table, but that he is not allowed to update the table. You see the deny permission here. You might think that would kind of conflict with this whole idea of data writer. Well, there's really three ways to write to a database. You can update the database by changing data that's already in there. You can insert new data into the database or delete data from the database. Now, his role membership will give him all delete, insert, and update, but this individual permission has removed the update capability. So all he'll be able to do is insert new data or delete old data. If I just wanted him to be able to insert new data, I might deny him delete permission within that particular table as well. So this is how permissions are sort of controlled on a per user basis. It's kind of a pain in the neck to control things on a per user basis because every time you get a new user or someone leaves, you have to go in and manage the permissions. And that's why these database roles are so useful. Unlike the server-wide roles, you can create new database roles. I can say my role is going to be insert only, and I'm going to let it be owned by the DBO user. Most things are owned by DBO. And the securables for this, we'll say we're going to grab all the tables out of the database. There's my table. And this person is only going to have insert permission granted to them. So now that I've created that new role, anyone who is added to that role will pick up those permissions. And that's a much more effective way of managing permissions within the database. So those are the two real elements. Users, which are a way of mapping logins into the database. And not just logins either. Let's create another new user. You can see that if I've enabled certificates and keys, I can actually create a user that doesn't map to a login, but rather maps to a certificate. So that's another way of identifying themselves to SQL Server and gaining permissions in this database. So users are the first element. Users are either assigned permissions directly, or better, they're placed into database roles, and that gives them their actual permissions. This isn't unlike domain management for Windows. You create users and you put them in the groups to give them permissions. There's another type of role that lives within a database called an application role. Here we give this a name. We're going to give it a password right here. And then we can either assign it to roles or we can just give it explicit permissions. So we'll say this has got the ability to insert data into this particular table. Application roles aren't designed to be used by users. As the name implies, they're designed to be used by applications. Now, in an earlier nugget, we talked about the fact that database developers a lot of times like to hard code or not database developers, I should say, application developers that use a database like to hard code their applications so that they have a password and a username built into them. Well, that's really what the purpose of an application role is. Rather than hard coding a SQL Server login account into the application, they simply touch to this database and authenticate, if you will, using this application role, which is private to the database. See, this way if the application is compromised, you don't have a server-wide login hard-coded in there and you wind up compromising the entire server. You've just got this application role hard-coded in there, and you've only exposed or compromised this one particular database. So in this fashion, the application does not pass the user's credentials through to SQL Server. The application identifies itself by this application role, gets whatever permissions this application role define, and then whatever user is using the application winds up being restricted by these same permissions. So it's just really there to accommodate a different method or a different model of programming for applications. So those are the main elements of database security: users and roles. Of course, user can have individual permissions. Now we're going to kind of expand out into the broader world of security. And one of the first things we need to talk about is ownership. So let's go over to this table I've created, and you'll notice that it's dbo.mytable. DBO is the owner of the table within the database. It's the user account that's sort of responsible for it at a top level. The owner of an object can do anything they want to that object, regardless of their other permissions. Now, if we go to this database's security and look under users, you'll see that there is a DBO user, and that's who owns that table. Pull open the properties of this table, and under permissions, we can see that the schema is owned by DBO. We can change that if we need to. We can change it to another owner. There's a SQL command that will allow us to do that. But the reason this business about ownership is important is because of something in SQL Server called permission chaining. So let's say that we have a table in the database, and we're going to say that the table is owned by DBO. Now we've also got a stored procedure, we'll call it sproc, which is not owned by DBO. This is going to be owned by Don. And let's say that we've also got a view, which is another way of looking at a table, usually a subset of the columns within a table. And let's say that this is also owned by DBO. Now, let's take a look at just the permissions on some of these things. Let's say that table is going to allow the user, just the user DBO. Nobody but DBO is allowed to touch table. The permissions for this stored procedure are going to allow DBO, Don, and our user Dave. Any of those three users are allowed to execute that stored procedure. This view is going to allow DBO, Don, or Dave. So any of those three users can look at the view. And of course this view is built on this table, and this stored procedure is going to seek to modify this table. So here's how permission chains work. Let's say I'm Dave. I try to access this view. SQL Server needs to check and see if I have permissions to it. I do have permissions to it. Because the view is owned by DBO and the table that the view is using is also owned by DBO, permissions are not checked again when the view goes through to the table. This is one of the reasons that you'll see most objects in databases owned by a single user. The permissions are only checked the first time someone tries to access an object, so long as the owner remains constant through this chain. Then permissions aren't checked again for subsequent underlying objects. See, that means I don't have to give Dave direct permission to the table. If Dave tries to touch the table directly, he won't be able to. He can only access the table through this view, which lets me, for example, cut down on the number of columns he can see. By giving him access to this view, I give him one way to look at the table that might be a subset of it, and I don't have to give him permissions to the table itself. Now let's say Dave tries to access this stored procedure. Well, Dave does have permission to the stored procedure. Okay, so he's allowed to access the stored procedure. Now the stored procedure needs to access this table, but the ownership chain is broken. Therefore, SQL Server has to recheck permissions on the table. Dave does not have permission on the table, and so ultimately his use of the stored procedure will fail. So that's how ownership chains work within SQL Server. They're a very important part of SQL Server's overall security model. And the next security thing we're going to talk about is encryption. SQL Server 2005 introduced the ability to encrypt individual columns, such as the name column or the address column within a table. This created a decent amount of difficulty for developers because in order to go to an existing application and enable this encryption, you had to really change the way your code works. Your code had to understand that data going into the column had to run through an encryption routine, and data coming out of the column had to run through a decryption routine. At the same time, their performance wasn't exactly awesome. So SQL Server 2008 introduces something new called TDE, Total Database Encryption. The idea here is to handle the encryption at the database level, right within the core of SQL Server's engine. Developers don't need to do anything different. They can really act as if the entire database is unencrypted because as SQL Server pulls data off the disk, it takes care of the decryption. The real purpose of total database encryption is to protect the data that's stored on the disk so that, for example, if the disk is stolen or someone gets inappropriate access to the database file, they won't be able to use it. There are a couple of features in Windows itself that are real similar to that. Windows offers the encrypting file system, which does something similar. So let's look at some of the big differences between total database encryption and what's built into Windows. Windows really has two features that we're going to talk about. First, there's SQL's total database encryption. There's the Windows encrypting file system. And then there's BitLocker in Windows Server 2008. BitLocker does whole volume protection. EFS, actually let's just call that whole volume there. EFS is per file, and TDE is per database. Now already we can see some differences there. A database can consist of multiple files spread across multiple volumes. TDE will make sure that they're all encrypted. EFS would require you to encrypt each file individually, and BitLocker would require you to encrypt each volume that those files lived on. You might have other things living on those volumes that you don't want to be encrypted. From a performance standpoint, TDE is good on performance. We're going to call this perf check. It's designed for multiple things to be trying to access the file at the same time. EFS is not. We're going to call this perf x. Now, EFS is not a good choice for encrypting SQL Server database files. BitLocker is. It really doesn't have concurrency problems, so we'll call that perf check. And in fact, in Microsoft's guidance, they suggest that TDE and BitLocker can work well together if that's the level of encryption that you need. Now, something that's interesting about TDE is that it's not protecting data as it goes across the wire. Now, let's sort of look at a model of how TDE is built. We've got the database, which is actually a bunch of files sitting on a disk. We've got memory, which is where SQL Server is actually manipulating the data. And then we've got the network. And that's where SQL Server is ultimately sending the data. So TDE operates at this level, and for that matter, so does BitLocker. So TDE or BitLocker. When the data comes off of the database, it's decrypted at that point. As it sits in memory with SQL Server, it is decrypted. So therefore, as it is transmitted across the network, it is transmitted in clear text. That's why client applications don't require any changes. They're not seeing decrypted data coming across the wire. They're seeing clear text data. Now, that means if you're going to use TDE, or for that matter BitLocker, and you're concerned about protecting more than just the data as it sits on the disk, you also need to make sure that SQL Server is using HTTPS or some other form of encrypted communications, might be IPsec, so that the data is being protected while it's in transit across the network. So how do you actually set this up? And actually, this is tricky enough that rather than walking you through the steps and making you write everything down, I'm going to refer you here to Books Online. If you go to Books Online, go to the index and type TDE, you'll find TDE described as a topic. And if you scroll down through that, you'll see the exact steps for creating the total database encryption on a database. You're going to start by using the master database. That's SQL Server's master configuration. And in it, you're going to create a master encryption key using a password. Use a strong password there. And I don't mean an 8-character password that just has some gibberish. I mean like a 30-character password that would be really impossible to guess. Write it down on a piece of paper and lock it in a safe somewhere in the office. Ideally somewhere in a different office. So once you've created that master encryption key for the overall SQL Server, you're going to create a certificate, give it a name, and the subject will be whatever you want the name of the certificate to be. Then use whatever database that you want to apply TDE to. Tell it to create a database encryption key with algorithm. Now you can use AES_128. AES 256 is a little stronger. There are a number of different encryption algorithms available within SQL Server, and this help file actually documents many of them. Encryption by server certificate, and you're going to refer to that same certificate you created earlier. Execute that query, and then finally alter the database and set encryption on. So then execute this query, and that will turn on the encryption using that encryption key which came from that particular certificate. This is a really good help topic to go through. It gives you a lot of the overview of how it works, shows you a little functional diagram of how the data works and how the keys are stored. Now, a downside of using this exact method is that the encryption keys are stored in SQL Server itself. So there is definitely a danger there. If someone is able to steal the entire hard drive and you're not using BitLocker, then they're going to be able to get that encryption key out and potentially, without really too much trouble, decrypt the database that you were trying to protect. So that's why SQL Server 2008 supports something called extensible key management. That allows third parties, EKM, extensible key management, is designed for third parties to provide their own key management capabilities to SQL Server. One way you might see that is in something called a hardware security module, or HSM. Sometimes that's a USB connected thing. Sometimes it's a module that's actually built into the motherboard of a computer, and that's where the keys are stored. So rather than storing those keys in the database where they can kind of be easily retrieved, EKM lets you store the keys somewhere where they're much safer. It's important to understand that EKM is not some user interface that's built into SQL Server. It's a connectivity option that SQL Server provides, but you need a third-party key management app to connect to EKM to actually provide the functionality. So there are a few caveats about total disk encryption, or total database encryption, that we need to talk about. First, total database encryption will encrypt your MDF and NDF database files. It will encrypt new entries in your LDF transaction log. That means after you enable encryption, you really should go perform a full database backup so that the transaction log gets truncated and all further entries in the transaction log will be encrypted. Otherwise, you will have unencrypted stuff sitting out there in the transaction log. This will not encrypt any file stream files if you're using those in your database. So those are potentially a weak point, and that might be why you want to use something like BitLocker on the volume that contains those file stream files, not EFS. EFS wouldn't really work anyway because SQL Server is always creating new files. Plus, again, EFS has really got some concurrency issues that you're not going to want to have to deal with. Now, in terms of backups and restores, backups will be encrypted if the database is encrypted, and that's excellent news. That means the backup itself isn't a problem. If you're using snapshots, database snapshots, something we'll be talking about in a later nugget, those also get encrypted with TDE. So really, it's a great solution for encrypting and protecting the storage. Again, TDE is not designed to protect communications across the network. Anything that leaves SQL Server is going to leave in clear text, so you're going to need to implement other means to keep those things safe. Now, I said earlier that SQL Server also supports the older SQL Server 2005 way of encrypting data on a per column basis. And here in Books Online, I've looked up encryption and selected About Encryption. You might also select topics like columns if you want some how-to information on how to enable that per column encryption. There are still a few instances where you might want to do that. For example, if you just need to encrypt a particular column and you don't want to encrypt the entire database, and you don't mind the overhead of modifying an application to handle the encryption, then this can be a good solution. Something that's interesting about per column encryption is that each value within the database can have a different encryption key. So let's take an example of a table, which again just looks like a grid. And we've got our columns and our rows. And let's say that we've got A, B, C, D, and E columns, and we decide we want to encrypt just what's in column D. SQL Server is capable of using a different encryption key for each row of this column. So this might be user 1's encryption key, this might be user 2, this might be user 1 again, this might be user 3, and so forth. The idea here is that the data is really per user. If another user queries this row other than user 1, they're not going to be able to see the data in that particular column. So it's a way of securing data more on a per user database than on a per database basis. So that's kind of one of the reasons you might want to use that. And again, it's worth reviewing the information in the Books Online under this type of encryption. About Encryption is a good place to start so that you can really see the exact steps involved in doing that. It is relatively rare for larger organizations, or really any organization, to use this without planning about it in advance. Simply because the changes you have to make to the client applications to deal with that level of security are not minor, small changes. So existing applications will be better served usually by TDE, but if you're looking at a new application or a rebuild or a re-architecture, then this is there as an option for you, and it does have some instances where it provides unique capabilities. Okay, the last area of database security we're going to talk about is really more of a management thing than security specifically, but it provides a good way to manage security amongst other things. So we might as well talk about it here as anywhere. And this is SQL Server's policy-based management framework. So I'm going to go all the way up to the top level of the Object Explorer here in SQL Server Management Studio, dive into management, and look at policy management. Policy management starts with conditions. For example, I've created a condition here called SP, or stored procedure recompile, is set to true. So let's look at this. This is going to be looking at the facet called stored procedure, and specifically within that facet, it's going to be looking at the recompile attribute to see if it is false or not. So let's sort of create a new condition so you can see this all put together. The facets represent all the different elements of SQL Server. You can see that there are a lot of them in here. Let's go with table, and now field will show me all the different things that have to do with a table. Let's say table has clustered index equals true, and we'll name this table has clustered index. So this condition is just going to check a table to see if it has a clustered index. It'll return true. The condition will be true if the table does. The condition will be false if the table does not. So you start by creating those conditions, things you care about within a database or across the server. Then you can create policies. So let's create a new policy that uses that new condition. Make sure tables have a clustered index. The condition we're going to check for this is down here. Table has clustered index. and we're going to check it against every table in every database. And let's say we're doing this not for security, but for performance reasons. We want to make sure that every single table has got a clustered index so that we get good performance out of our tables. We're not going to restrict this to any particular servers, and we're going to evaluate this on a demand basis, which means we're not going to look at this every single day. We're only going to look at it when we're interested in going through and sort of evaluating our databases. So let's click OK there to create the new policy. Make sure tables have a clustered index. The little down arrow icon tells you that this is not enabled for automatic checking. Alright, so now right-click that, hit Evaluate, and it will evaluate this on demand. We can see that the evaluation failed. Not every table in every database has a clustered index. So let's scroll up here through the list. Oh, there's the problem. It looks like our reporting services database does have a table called report schedule that does not have a clustered index. So this is kind of a neat little tool. We might then go back and, we've got a couple more. We might go back and modify our condition or our rule or policy so that it doesn't evaluate some of these more system style databases, so that it just focuses on our databases. But you see how this operates. Now I've got a couple of others in here. Let's take a look at this one called owner is not sysadmin. This one is being evaluated on a schedule. It's going to happen nightly, and it's going to check every database to make sure that the database owner is not also a system administrator. Kind of a security rule to ensure separation of duties. I don't want my system administrator owning everything. I want a dedicated owner account within each database, just so that there's some separation there. The next one is ensure auto shrink is on. This one's going to execute on demand, although look here. With this particular type of condition, checking the auto shrink property of a database, I can say that I want to check this automatically all the time. And if you find that this property has changed, I want you to log it to the application log for me. That way it's something I can review. Now, that on change log only is not available for every single facet and property that you might want to check. So what you do is you create your condition first, and then the evaluation mode drop-down will change, and if it's something that it can detect changes on and log, then it will do so. I've also got one that says stored procedure recompile is false, and this one is set to on change prevent, which is yet another option that can be displayed depending on exactly what your condition is. So this is checking every stored procedure in every database. My check condition here is actually misnamed. I'm checking to see if it's false. So if this is changed, SQL Server will actually prevent the change from occurring. SQL Server does this by adding a data definition language, or DDL, trigger, so that every time the SP recompile property is changed, the trigger activates and then undoes the change automatically. There is a real trick to this, though. Let's go into the server properties, and under advanced settings we will have allow triggers to fire others. Now, this is called nested triggers, and it's set to true usually in a database. If this is set to false, then those DDL triggers will not work. So if this is set to false, then my prevent will not actually work. It'll let me set it all up, but when SQL Server tries to actually prevent the change, nothing will happen. So this policy-based management framework is good for configuration management in general, but security management is one area where it's particularly useful. You can define policies that look for particular levels of security configuration, evaluate them on demand or on a schedule, and in many cases have SQL Server prevent changes from occurring to key security configuration elements. Again, not just for security, but security is one area where this particular feature really does shine. In this nugget, we've looked at SQL Server's database security. We started with the basics of database security, which include objects, users, permissions, and database roles and application roles. We looked at some of the encryption options, including per-column encryption, total database encryption, and sort of the impact of EFS and BitLocker on SQL Server. And we finished by looking at SQL Server's policy-based management framework as a way of creating security policies, ones that can help enforce security, evaluate security, and so forth, as well as SQL Server's audit plans. I hope this has been informative for you, and I'd like to thank you for viewing.